so I kind of have this notebook set up again. There's a different notebook for the making changes. And now I've got a poll for for people. I'm not sure what people would rather see. So I can, let me share my screen. And then let me ask people. So I can either just walk through this notebook here and there'll be some kind of text, and then there'll be some code cells that we actually are going to execute. So it's a question of, do you want to see things like this, or would you rather that I displayed the slides like this, so that it's this kind of view, and then jump back to the notebook to do the execution? I don't know, I'm trying something else out. I want to make it a good, if anyone has any big feedback on that. Okay, well, we'll start like this, and then maybe we'll jump back and forth, because I think it's just a little bit more readable like this. So, okay, so we're going to kind of walk back a little bit and say, you don't have to be a version control maestro yet. You just want to do your run, and you just want to make some really simple change. How do you do that? Let's just back up to that. So we're going to start with just like tweaking a setup. And so hopefully by the end of this, people are able to, be able to say, okay, these are the basic choices that I have when I'm interacting with that high-level IMSI tool, that you're able to set up experiments for different supported experiments in a model. So Clint showed you one example for a PI control run earlier, just copying and pasting that quick start guide. But what happens if you wanted to do a different experiment, like an SSP? How would you do that? And then even if you're doing an SSP, if you wanted to modify some basic properties like the end date or the restarts, how would you do that? And then we'll hopefully come to a second part where we make some bigger changes, but let's just go through this one for now. Okay, so as the entry point to this, let's just talk a little bit more about how we do the configuration using this, what I would call IMSI configuration hierarchy. So what we have is basically within the CANism repository, and Clint did show that directory, but there's a bunch of files that are JSON files, so they're machine readable and human readable, and they define configurations for machines, for compilers, for different models. For example, here's just an example for CANism 5.1, P1, different experiments like the different CMIP6 experiments. So everything about the configuration is basically defined in these files, and that's ingested into kind of an overall IMSI database when you run the IMSI tool. And so there's a program that you run, and so that gets ingested into the tool as well as the user input. So like when you say IMSI setup, like you did a few minutes ago when you set up that run and you told it some information, like you told it this is the model that I want to use and this is the experiment that I want to use. So it takes that user input and it kind of applies that to this whole database to pull out the things that are relevant to your selections. And then it will create that IMSI configuration $run ID file that Clint spoke about, and also the config directory, which contains all the files that the model will actually use at runtime. So yeah, so again, there's a link here to where that is in the model repository. You can go and kind of like check out any of those files. And we're kind of doing this. It's a very kind of like, it's relative to what we have internally in ECCC now. This is like a very like well organized way. Like we're structuring our configuration data in a much more like rigorous way that we can use machine parsing on it like much better. And we can also use inheritance, which allows us to define things very clearly. So for example, like an SSP can just inherit from a historical experiment because its many properties are the same, instead of redefining everything. So it's kind of, that's the reasons that why we're doing it. Okay, so let's just get into doing a different setup. So instead of doing a PI control run, let's say that we want to do one of the other supported runs. Now remember, there's only like 6 or so supported runs, but if we want to do one of those other 6 other than PI control, we can pretty easily do that. So basically for an SSP 370, in that call to IMSI setup, we would just specify the experiment being the correct experiment name, and then the IMSI tool will take care of putting all the correct files in place and everything. And then we just follow those same steps of mz build, save, restart files, and submit. And that will run an SSP 370 simulation. You as the user don't have to do anything, then just change that one variable at the command line. So that's the only thing that you have to do in order to do a completely different experiment. That experiment actually has hundreds of different settings compared to the other one. But as a user, we are abstracting that all away. You don't have to know about it, because if you had to go and change those all manually every time, I guarantee you, you would make a mistake. And we made mistakes when we did it that way. And that's why we kind of went away from that. So, okay, so I'm going to jump to the actual notebook now. So this is exactly the same content, but I just have this cell. So, okay, so we're doing exactly what Clint demonstrated earlier, going to the Scratch directory, we're sourcing that MZ tool environment, and then we're doing the MZ setup command, just like we did before. And the only difference here, instead of saying experiment is equal to CMUP6 PI control, which is what you would have done last time in Clint's demonstration, here we're doing CMUP6 SSP 370. Hopefully this is kind of pretty readable, is it, for everyone. And again, we say a run ID, and here I'm just assigning a run ID user, blah, blah, blah. So anyway, if anyone has this notebook, you can execute this, and this basically will work. So, well, yes. So what happens is we hit that command, and MZ is going, and the way that our setup works is we pull everything from version control. We don't rely on a bunch of stuff on disk. So this is all about scientific reproducibility is the reason why we do this, portability and reproducibility. So what you can see all these messages coming out is it's going to GitLab, and it's literally cloning that whole full source code down from GitLab and setting everything up in a directory for us to use. Okay, so it's completed. And okay, so let me just open up a little terminal here. So if I'm in my Scratch directory, and this new thing just got created here, NSWAT SSP 370-1. So I could go into that, and yeah, that's been set up. I'm just going to go back to the notebook. Okay, so so now we've got that a new run set up for SSP 370. And again, if I wanted to just run that without any changes, I could just do exactly the same steps as before. MZ build, save restarts files, MZ submit, and it would run the default SSP 370, kind of no questions asked. And I claim, at least right now, that it will make it a bit identical to the ones that we've done before. And I have not experienced that it doesn't do that yet on Niagara. So, okay, but so that's fine. But what happens if we want to change that experiment, if we want to start making some tweaks to it? So let's start by making some small, like one-off changes to the simulation, and we'll talk about bigger changes later. But we can reflect that in general, we can change an experiment by either changing input settings like nameless parameters. We could change the input files like forcing files, initialization files, or restarts. Of course, we could change the source code. But we can also change kind of simulation characteristics without changing the model result. Like we could say, okay, I don't want to run the whole of SSP 370 to 2100. I only want to run for 10 years. So we could make some changes like that. So what I want to do is I'm going to just open this up in my, so I've got the, sorry, let me just find out. Okay, yeah, here's the thing that was set up. So I'm just going to open up a few files. So under the config directory, if you look in there, there's a folder called .simulation.time.state. And if I open that up, this is for the simple shell sequencer that we're using on Niagara. This controls the timing. So it's saying that the start year is 2015, the end year is 2100. That's the defaults for that experiment, and it's going to start in 2015. So this is a file that users generally don't have to edit. That's set at that's set by default. So then there's also a few other things like in the config directory, for example, there's a shell parameters file, and this contains like many variables that are also going to be used at runtime. And I'm I'm mostly just opening these here to show you that when we alter the IMSI configuration, these things will be updated automatically. And this is important because if users just go into these files directly and start just like editing by hand, which you can do, but there's a problem because there's a whole stream of changes that have to be made consistently across many different files. And if you forget to change one of those, then things won't work. So we use the tool upstream to do the changes, and then it applies it in the actual files that are used by the model in a kind of self-consistent manner. At least that's the theory. Okay. So let me go back to my notebook. Okay. So we also, yeah, the other one that Clint did point out is that there's this configuration file for the IMSI configuration, which is the JSON file. So that's in the top level of your experiment. There's this file called IMSI configuration, then runid.json. And Clint pointed out this has got hundreds of lines that this defines everything. This is like what I would call a single source of truth that defines everything about this experiment, how it's going to be run on the computer and everything like that. And so really, this is what defines the configuration. And when we're going to modify things in here in order to then apply them for our run. Okay, so let's just do this example of changing the simulation end time. So in order to do that, we're going to open this file. We're going to search for a particular section, which is called compset_config. And instead of going to year 2100, we just want to go to year 2020. So we're going to edit end year, and then we're going to apply those changes. Okay, so I'm going to go to this file. I'm going to search in that file for compset_config. Here it is, and we can see here that end year for this is defined as 2100. I don't want that. I want 2020. So that's my modification. I only want to run until 2020. So I'm going to save that file. That's the change that I've made. Okay, and then what we need to do after we apply a change in that file, we need to run IMSI config for that change to be applied. So I'm going to run IMSI config here, and it will go and make changes that it needs to make for that to then be applied consistently. And just so, yeah, so we made that change in that file. Now, because we've run IMSI config, if I go to simulation.time.state, you'll see that end year is now set to be 2020. So it's updated that, but it's also updated the shell parameters file. You'll see in various places run stop time is now 2020. So you didn't have to know, oh, and that could show you other places that have been changed too, but you didn't have to know that. You just changed it in that one place, write IMSI config, and then it will take care of the details. That's the whole point of abstracting that from users. Okay, so, oh, sorry, wrong one. Okay, so we've successfully changed the end date of the simulation. So if I did that now, I could, again, now if I submitted that run, instead of going to 2100, that run would only go to 2020. So this is not a huge one. But okay, let's look at a slightly more advanced thing. So imagine that I want to change the restarts. So we can go back to that file, and we can see that the restarts are defined on the basis of something which is called the parent run ID and the parent branch time. It's also in this compset_config, and that's just described in this text here. So as I mentioned before, when you set up this experiment, just because of the way we've set up, it will automatically select for you a good, sensible default restart. So the parent run ID here is set to be version 5.1 historical ensemble member number 1, and the parent branch time is 2014 month 12. So that's sensible. So this SSP 370 experiment that we're going to do, it's starting from the end of a historical run that we did in Environment Canada, and the restart that it's coming from is from the end of 2014, which makes sense because SSPs start in 2015. So that's all sensible, but maybe for me, maybe I want to do an ensemble. So maybe I want to do 3 runs, and I want them all to start from different restarts. So let's say this run, I don't want it to start from historical ensemble member number 1. I want it to start from a different historical run. How do I change that? Okay, well, of course we can change the value here, but I want to point out a detail, which is I can't just change this to anything arbitrary. that I have to change it to something that, number one, makes logical sense, and it's a functional restart, but it also has to exist in this global database, or at least in your in the global database that we provide for these runs. So if I could just go back to the tutorial, if we list this project space that CP4C has of all the restarts, we can see that actually we've put restarts for 10 historical members there. So that's kind of currently what's available. So any of these runs would be valid options for me to use. If I wanted something else, then either I'd have to generate it myself by redoing myself a historical run, or I'd have to ask Environment Canada, hey, can you guys please give me some other restart that I'm looking for? But currently that's what's this directory shows what's available. So I'm just going to here change it. I'm going to say, okay, I actually want to use the historical member number 8 for the parent run ID. And I'm going to save that. And so then again, if I do that, I have to do this mzconfig step in order for that change to be applied. So whenever I make a change to that JSON file, I then have to do mzconfig. And of course, I have to do this before I save the restart files. So if I save the restart files first and then make this change, like, yeah, you have to do it. That has to be in the right order. So let's just go to the terminal quickly again, and let's just look. We don't have any output directory here. We haven't saved any output files yet, so that doesn't exist. But after after we do the save restart file scripts, that will be created, and I'll show you that in 1 second. So okay, let me just make sure. Okay, I've changed that to 8. I'm going to save it. I'm just going to check. So like in the shell parameters, okay, so we can see that this shell parameters, this is all still set to member 01. It's because we haven't done the mzconfig step. After we apply mzconfig, this will be updated. Okay, so here I'm going to do mzconfig, and then I'm going to save the restart files. So I'm going to execute that. And we can see that it puts all this output here. And what actually happens, it goes to the global database, it looks for that parent run ID in the database, it finds it, and you can see it's talking about run ID in, and it's finding that historical member 8. It's taking that, this is the save restart files now, it's taking those restarts, and it's producing a copy of them in my local run. So that's what we do. We take the restarts, we rename them, and we put them in a new place to be used for your run. This is the standard practice that we use. And so it's gone there and it's so-called saved those into the local database of the run, so that can be accessible to your run to use those. So if I just go back to the terminal and I list things, we can see now there's an output directory. That output directory now contains these restart files. And you can see that they've been named for my run. They've got this name, nswat SSP 370 number 1. So they've been named, but they come from that other parent upstream, right? So that is what save restarts files has done for us. It's also created this SQLite database that just keeps track of files that are used by the run. Yes, okay. So we've managed to basically do 2 things so far. We've changed the end date of the simulation, and we've changed the restart files that go into it. Okay, yeah, just listing, you could see that those files were created. Okay, so yeah, we don't have a huge amount of time if we want to keep some space for questions. So I do want to go on to changing some other files, but I see that Paul has his hand up so far. So yes, Paul. Oh, I don't hear you. There you go.
If you lost track of what you've done, and so you modify the JSON file, right? And would you be looking for differences from the checkout from the repo? Like, is that what you would do? You know, I'm trying to, because you're changing, like, this master file has so much information in it. I can see bad things happening, people making mistakes there. So is there an easy way? This is a food for thought for later. I'm just wondering about, in practice, how users can keep track of what they've done. You know, it seems very easy to change that file, but also easy to make mistakes because there's so much detail in it. And
Exactly. So, I mean, I think that this is for, as I kind of alluded to at the beginning, this process is recommended for making like one-off changes that are trivial, like to end date or the restarts that are easy to keep track of. If we're going to go in there and start changing a lot of stuff, and actually that I want to reuse later, oh, I'm going to fundamentally change how this experiment works, this is not the recommended way to do it. We would do that in the version control system so that you could see it explicitly. And if I have time, I will show you a quick example of what that looks like. But yeah, that's how we would do it. So yeah.
Thanks. Yeah.
Okay, so let's just talk about changing other files. So yeah, restarts is one thing, but imagine if I wanted to change a forcing file. So if I wanted to change a forcing file, let's say I wanted to change the greenhouse gas forcing, how would I go about doing that? Now, this is a little bit more advanced. So let's just go back to our JSON file. Let's just go, we can look at our components. Okay, components, CanAM, and there's something under CanAM and all the model components called input files. And this tells you this literally is every file that model is going to take in is listed here. It's very explicit. In our internal Environment Canada system, good luck finding one person that can tell you exactly which files are read during which experiment. But in this system, this is, I guarantee you, the only things that are read in. Which is why the system is nice and why we're going to try and move towards it. But so what we can do is we can identify here that there's a file, there's like a greenhouse gas file, and we could say, okay, well, so yeah, like greenhouse gas scenario. So what happens if we wanted to modify that somehow? We wanted to have a different trajectory of emissions or something. Okay, what would we do? So I'm not going to tell you the details of how you're going to modify that file. I can't tell you that. That's some discussion that you have to have with a scientific expert that's knowledgeable about the file you're going to change. What I'm going to show you is at the infrastructure level, how you would go about that. So the first thing that I'm going to do is I'm going to source some of these files that just give me access to a couple of tools. Well, geez, I'm using this term access, but they will put onto my path some things that I need, and they'll give me access. They'll give me scripts. One of them is called access, and one of them is called save. So that's what sourcing here is doing. And so I alluded to this fact that we have this database that handles storing and making available to runs files. And so we have these scripts that are used to interact with files in the system, and access kind of gets files and save places files into a different location and into a database. So what I'm going to do here, I'm going to get the original file, and I'm going to access just the original file name, and I'm just going to put it into a name which is I call original SSP 370. And I got this original file name literally just from here. I just copied this name and I just pasted it here. So I'm going to access into that. And then I'm going to modify that file as I need to modify it. Again, I can't tell you exactly how you're going to modify it. That file is actually going to be in CCCMA format. There's a whole bunch of detail I don't have time to go into, but this applies for any file going into the ocean or whatever. Like you would modify it. So for me, I'm just going to copy it into a new name. I'm just going to copy it into user modified file. That's all I'm going to do. Then I'm going to save that file, which is going to make that new modified version available to my run. And then what I'm going to do is change the mzconfig to use my new file, not the old file. And I would rather do that editing the file, but here I've just put in a sed command just to make sure it happens. And then again, of course, we have to mzconfig to apply that change. So that's all laid out there. I'm just going to execute it, and it's going to do it. The computer is going to do it now. And what we'll see, so yeah, you see a bunch of the module loading stuff happening because we're sourcing stuff. Okay, so it's done it. Okay, now if I come and look in mzconfig, okay, now normally I would manually edit that, but I just put that sed command in there just to make sure it happened, but that's changed. And if we went and, for example, just to verify that this had been applied under config, I'm just showing you another little thing that exists. There's something called mzget input files. And mzget input files, it's going to get the greenhouse gas scenario. And here you can see when the model runs, this is literally the script that runs. It's going to access into greenhouse gas scenario Neil's modified SSP file. So I've successfully been able to tell the system to use a different file than the default one. And in theory, I've edited it. I've modified that file, but of course, in practice, we didn't do that. Okay, so I hope that kind of makes some sense. And again, this notebook is there, so people can work through it at their own pace. I know we're going kind of fast. I think, yeah, so a few other things. We could change name list parameters in the same way. So for example, if I came here and I looked in the CanAM name lists, so under the mzconfig file, there's a whole bunch of name list options that are defined for CanAM. And for example, here's one, which is called with solvar. Let's say I didn't want that to be true. I wanted that to be false. Okay, well, I can save that. Then I can again mzconfig, and it will apply that change. Now, the reality is that what appears here is only a fraction, actually, of the total name list parameters, because what is listed here are just differences on the default. If I wanted to get access to all those other ones, I could actually go and edit. I could edit the name list if I wanted under, like if I looked under config, CanAM name lists, there is a CanAM settings that contains a lot more stuff. And I could go and edit that, and that is actually what would be used. But again, you know, you have to be careful that you can't just willy-nilly edit stuff there and just expect it to work. Like, it has to be logically coherent, right? So, but just to point that out. Yeah, so it's basically like a similar process in terms of doing name list changes. You can either edit the name list directly, or you do it in that mzconfig and do it that way.
So Neil, just to, so the JSON file, does that supersede, or does it come? Does that overwrite what you when you edit the name list, say in CanAM settings? Which gets kept, the JSON or the?
Okay, so that's exactly what mzconfig does. So yeah, good point. Okay, so let's just look at that explicitly. So if I look in config, CanAM name lists, CanAM settings, right now, with solvar is set to true. So that's going to be true. Now, that is not going to change unless I do something. So even though in the JSON file, I've set it to false, it's still true in the actual name list that's going to be used in that config directory. Why? Because I haven't executed mzconfig. So if I save this and I go, I think I have this in my notebook. Let's just see. Okay, I didn't actually do it. Okay, so I have to open a terminal, and I have to make sure that I have mz sourced. Sorry, this part is.
Don't worry. But you're saying like if you run mzconfig, then that will get that will.
Yeah, no, I think it's worth showing it.
Okay, sorry. Yeah.
Let me just. I just need to put that into my environment. Okay, so I have mz. So then if I say mzconfig, it's going to go and apply it. Okay, now if I come and look in CanAM settings, solvar with solvar is now false. So you see that mzconfig applied the change. So you make the changes in the JSON, mzconfig applies the changes. So there's a separate step. If you don't do mzconfig, it will not apply the changes.
But if you,
the system doesn't magically do it. The only time that the system kind of like magically does it by itself is during setup. It does all the mzconfig stuff in the beginning to give you the first sensible thing. But then any changes you make, if you want them to be applied, you have to mzconfig it.
But users could be tempted to edit CanAM settings directly, but that's not the recommended practice. Is that correct?
That's not, I mean, there's a bit of nuance here. I would say for anything that does appear in the config, and we could actually force everything to appear in that config. We don't currently, just to keep it dry, but probably, yes, if the thing appears in that config file, the recommended practice is to edit it there. And the reason for that is because sometimes when you change a value there, it changes maybe multiple places downstream, and you might forget one of those. So it's easier just to let the tool do it programmatically. So that's the reason. But yeah, there might be cases where, oh, I know I'm just editing this one nameless parameter that's standalone, and it's safe for me to do it just directly in the name list. Okay, then that's fine. But there's a kind of a degree of implicit expert knowledge there.
Yeah, I would like to elaborate on that. That basically, if you're modifying things in the config directory, just note that you're kind of taking responsibility to ensure that you're not accidentally overwriting things, or you set settings correctly. Because it is totally valid for people to do it, but it does just require a bit more understanding of the system. So the recommended for learning and using the stuff consistently would be the JSON file with imzconfig.
But it's like generally, you probably wouldn't be making changes exactly in this way. Like if I really wanted to modify the experiment, I would do it in a different way. And I'll show you that next, and it's going to have to be fast because of time. So I'll take Russell's question, and then I'll just show you how we could apply a whole bunch of changes and save them for reuse later, because everything that I've done so far only applies to this one run that I'm setting up. What happens if I wanted to change these settings for many SSPs that I wanted to run, and I wanted to share it with a friend? I wanted to share it with Christian. How would I do that? So I'm going to show you that next quite quickly. But yeah, Christian, go ahead.
No.
Oh, sorry, not Christian. Russell. Sorry, Russell.
No worries.
Christian's face is on the screen.
Yeah. Just quick question: if something is in the sort of master name lists, can you, and it's not in the JSON files, can you add it to the JSON files and then trust that it's going to, do the right thing and update everything correctly?
Yes, basically, then that's what we're going to essentially do next in a way. Yeah.
Okay. Yeah. Sorry. Getting ahead.
Yeah. But that will pretty much be the case. But again, like let's also, we should be honest, right? This is a system that's a work in progress. We are still beta testing on users how the workflow for this works. There are many advantages to it, but there's also still kind of these details that honestly we are working out. This system hasn't been used in this context for super widespread development, like this literal like JSON file thing. So yeah, I mean, we're modifying as we go. Okay, so let me just see where are we? Okay, so we've gone through things. Do I have two of these open? Okay, so yeah, if you wanted, so we do the name list. If you wanted to change the source code, again, like when you got that run set up, there's that CanESM directory. There's the CanESM directory that has all the source code. I could literally go into CanAM, open something up in physics. Okay, let me open up a random file, clouds, open this file. Oh no, let's say.
You picked the fixed format one.
Times 100. Okay, what's that gonna do? I don't know. Okay, now if I just go and imz build and then imz submit, it will run it with that change. So as long as I make the change in the source code before I doing the build, or even if I have builds and then I decide afterwards, hey, I want to change something, I can go change this, and then I could go and build it afterwards and it will update it. So yep, that's all I have to do to change the source code for this one run. Now, I don't really recommend working like that, but for this one run, that would work.